The Math Center presents Square Roots. In this presentation, we'll first answer the question, what is a square root? Then we'll look at perfect squares, and finally talk about how to simplify square roots. A square root is when a number can be multiplied by itself to create a specific number. We use the square root symbol, also known as the radical symbol, which looks like a check mark, to indicate that we are taking the square root of a number. A perfect square results when the number that can be multiplied by itself is a whole number. Let's first take a look at an example of a square root. If we write the square root of 25, this means we are looking for the number that when we multiply it by itself, we get 25. Because 5 times 5 is equal to 25, then the square root of 25 is equal to 5. We say that 25 is a perfect square, since its square root is a whole number. Many numbers are not perfect squares. For instance, if you put the square root of 2 into your calculator, you get a long decimal answer that is about equal to 1.414. It is important to know the first few perfect squares, since they pop up in simplifying square roots, factoring, and many other applications. Being able to recognize a perfect square will make your life much easier. We have a list here of the first few perfect squares. One is unusual because it is its own square root. The square root of 4 is equal to 2, because 2 squared, or 2 times 2, equals 4. The square root of 9 equals 3, because 3 squared, or 3 times 3, equals 9. You can see the rest on this list. Look for multiples of these numbers when you are asked to simplify square roots. Now we'll talk about simplifying square roots. Here are the steps. First, you're going to identify the largest perfect square within the square root. Then you're going to rewrite out the problem using the perfect square multiplied by the leftover number inside the radical. Finally, you're going to simplify the perfect square. Let's take a look at a few examples of this. First, we are going to simplify the square root of 40. 40 is not a perfect square, so we can't remove the radical symbol completely, but we can do some simplification. We'll look at 40 and ask ourselves if 40 has a factor that is a perfect square. In this case, the largest perfect square within 40 would be 4, since 40 is equal to 4 times 10. We rewrite the problem with the perfect square and the leftover number. We now have the square root of 4 times 10. We can break this up into the square root of 4 times the square root of 10. Since 4 is a perfect square, we can simplify it to just 2 and remove it from the square root symbol. We still have 10 under the radical, so end up with 2 times the square root of 10. Let's take a look at another example. In this example, we're going to simplify the radical 72. So we're going to identify again the largest perfect square. In this case, it's 36. Keep in mind that in this number there are other perfect squares. However, 36 is the largest. So we're going to rewrite the problem with our perfect square, 36 times the leftover number. 36 times what equals 72? 36 times 2 equals 72. And we're going to simplify our perfect square. The square root of 36 ends up being 6, which we have outside the root symbol, and we're left with the square root of 2. So our final answer is 6 times the square root of 2. Thanks so much for listening to this presentation on square roots.